The last example of this section is that we are given here the differential equation which having constant coefficient a, b and c that we want to determine. We're given the solution, a general solution is given. We want to find the differential equation. You're doing this one before and we do the same thing here, but here is the difference. If you remember, we have the complex roots that was equal to alpha was equal to 1 and we get here m square minus 1 and that give me m square plus 1 equal to 0. The roots are plus minus iota. Then we're having here plus minus 3 iota. Then we take here m square is equal to minus 9 and m square plus 9 is equal to 0. So here I developed the equation that we can put the value of alpha and beta. We get the characteristic equation. The equation is m square minus 2 alpha m plus alpha square plus beta square equal to 0. We can see in this case alpha is 0, so this term becomes 0. Beta is 1, so we get here alpha square plus beta square that's equal to 1. We get m square plus 1 equal to 0. Here alpha is 0 again, so this term disappears. Beta is 1, so we get here 9 plus 0 is 9. So example, I have here 2 plus minus 3 iota. So my alpha is 2, my beta is 3. So when you want to solve it, what we'll get? I get here m square minus 2 into 2 is 4, 4m. Then alpha square plus beta square, that's equal to 4 plus 9 is equal to 0. That gives me the characteristic equation as m square minus 4m plus 13 equal to 0. I want to write the differential equation. I can write immediately y double dash minus 4y dash plus 13y equal to 0. Mainly I was telling when we have the complex roots how we can write our equation, and that's very important result to remember, that we put the value of alpha and beta and we'll get here the characteristic equation. So here is the case, we can solve it and we write here the solution of this one. We can write immediately the roots we are having here because we given general solution. We can write the roots, the values of m1. So my m1 is equal to minus 1. My m2 is equal to minus 2. This is here the complex roots. So here I get m2 and m3. So that's alpha plus minus iota beta. This minus 2 plus minus 4i. Now when I want to write here, my equation will be m plus 1 equal to 0. And here the characteristic form will be m square. Put the value of alpha equal to minus 2. I get here plus 4m. And put the value of beta equal to 9. We get here 4 plus 16 equal to 0. So we get here m square plus 4m plus 20 equal to 0. Now we take the product of these two. We get here m plus 1. And we're having here m square plus 4m plus 20 equal to 0. If you multiply them, I'll get here the result for this multiplication of these two. That's equal to m cube. And then we're having here plus 5m plus 24m square plus 5m square plus 24m plus 20 equal to 0. Now we are in position to write our general solution. So our general solution will be equal to the third derivative d3y over dx cube plus 5m, this is 5 d2y by dx square plus we have 24 dy by dx and then we are having plus 20y equal to 0. I can compare with this equation and can write here the value of ABC. Value of A is equal to 5, value of B is equal to 24 and value of C is equal to 20, and that's solution of our problem. So as repeatedly I mentioned, we can solve the problem from the list of the problem given in my notes and also more examples. Also you go to the textbooks. You can take any textbook of the differential equation, standard differential equation. You'll get more example. You can find the value of ZIL book, that's differential equation and boundary value problem. I mean, a very good list of the problem of not difficult level but also the middle level, not very difficult. If you want to find the very difficult one problems, then you're having the applied differential equation by Spiegel. That's having the three type problems, A, B, and C. That's here the normal one and the middle one and the very difficult ones. You can for the practice you can go there and you can get this more. You have a lot of literature. You can just find many books. You can search it on Google and you will get the soft copy of the books, and then you can just take more practice. I'm repeating this one. The mathematics you can learn by solving the problems. And these are very important part of our discussion, because mostly in engineering and nature we have the differential equation of second order. And if you are master with this one, then alhamdulillah, things are not very difficult for you to solve. So next discussion will be, we're having here the constant coefficient and homogeneous. Our next discussion will be non-homogeneous.